Hello, welcome to the video. In this lesson, we're going to be looking at section 11.5, where we're going to be choosing a data display. So, one of the things that we have to ask ourselves and we're going to have to answer is how can you display data in a way that helps you make decisions? First off, there are essentially two different types of data. There is the qualitative data or the quantitative data. All right, so qualitative data, by definition here, it says consists of labels or non-numerical entries that can be separated into different categories. When using quantitative data, operations such as adding or finding a mean wouldn't make sense. So, trying to, like look at like hair color in, you know, maybe like a classroom or looking at, uh, you know, individuals in like favorite subject in school, stuff like that. Uh, Not all of that can be, um, well, maybe that one can, but things that can't be put into value. Okay, so the hair color we'll go with. You know, there's no actual like number representation. So quantitative data says consists of numbers that represents counts and measurements. So like talking about like average cost of a you know of a car, or average salary of, or talking about minimum wage or something, something along those ends. Anything that has like can be attached with numbers per se would be under the quantitative data. So here, um, they asked you to tell whether it is a qualitative or quantitative. So the first one here is prices of used cars at a dealership. That's dealing with numbers, dealing with values. This is quantitative. Uh, for B, it's jersey numbers of a basketball team. Even though they are numbers per se, the number on the jersey is a symbol, not necessarily a numerical value to it. So this is an example of a qualitative. Okay. Length of song played at a concert, because it has, a number or a set put with data. This is going to be quantitative. And zodiac sign of students in your class, that is got nothing to do with data. This is qualitative. Okay. Here, they're asking you to analyze the data, then create a display that best represents the data. And then they ask you to explain your reasoning. So here, this one is talking about an eye color survey and number of students that have these colored eyes. Okay, so because there's no like number set, this is just a count, this is just a collection of data. This is an example of a qualitative. And since it's a qualitative, the best way to represent this data is through a circle graph. Okay, so first off, how we create a circle graph is what we're going to do is you have to add up the total number of people. So if you added 63 plus 37 plus 25 plus 10 plus 3 plus 2, you would get a total of 140 students that participated in the survey. Okay, so then from here, what we're going to do is I'm going to look at, from the 140, I'm going to look at a percentage of students that had brown eyes, blue eyes, hazel, green, gray, amber. Okay. So here it is about 45% of students have brown eyes. Um, about 26% have blue. About 18% have hazel. About 7% are green. About 2% is gray, and about 1% is amber. Okay, so if I were, I'll try to do my, so, so here's my circle. Okay, so what we're going to do is, so let's say here's the middle. What we're going to do here is, since a circle is a measurement of 360 degrees, in order to try to get as accurate as possible, um, the correct spacing for each um, piece of data, what we're going to do is you're going to take this percentage as a decimal and multiply it by 360. And then that is going to give you the degree on roughly you're going to create this circle graph. So 45%, which is 0.45, if you multiply it by 360, you get 162 degrees. If you look at the blue, that one's going to be about 93 degrees. If you look at hazel, you get about 65 degrees. Green is about 25 degrees. Um, Gray is about 7, so it was like 7.2 degrees, so you just say 7. And then we got about 3.6, not percent, this is degrees, my bad. So all these are the various degrees that are going to help us represent this particular bar graph. So here, what I'm going to do is I'll look at, the blue is 93. That's really close to 90. So I'm going to say, like, if I went like here and then just a little bit over, I'm going to say blue, and then I'll put the count of 37. Okay. I'll just kind of cross that off. Let me know that I took care of that. All right. So next, looking at what we have here. The brown is what, 162, so it's not quite 180. So I would say it's probably like right about there. So that's the brown. So that's 63. Okay. And then you can measure this with a protractor too. I'm just trying to give you an idea of this. So brown's been done. 65 degrees for hazel. So I'm gonna say it's right about there. And then hazel is what, 25. All right, so I got that. Now I'm into green, so that's about 25%. So 25% is kind of right about there. I'll say green. That was what, a count of 10. And now we're getting into the 7 and then the 3. So, okay, so here is your, gray at 2, and then again you have your amber at 1. Okay, so again, it's not exact. You can get more exact with the protractor and stuff like that, but it does give you a pretty good representation of this survey of which students have which color eyes. Okay, you can easily identify it. All right, and that is one of the things that they ask us at the beginning is, how can you display data in a way that helps you make decisions? So if you looked at this bar graph, you would be able to easily identify that, oh, students that have brown eyes is the most, and then you could kind of pick and choose from there, even if I didn't put the numerical value of how many students that had it. So from here, we have two different charts. One's talking about Interstate A, and one's talking about Interstate B, and it's speed of vehicles in miles per hour. So this is an example of a quantitative um, piece of data. And since we have two separate pieces of data in here, our best way to create a form of data that we can display that can help us make decisions is going to be a box and whisker plot. All right, so if you remember from the original lesson about box and whisker plot, we had to find the 5-number summary. So to save some time, um, I have those values there. So the smallest, so like if we looked at Interstate A first, the smallest value is going to be 59. Our first quartile is going to be 66. Our median is 68. Our third quartile is 75, and our largest value is 82. If we looked at Interstate B, my smallest value is 65. My first quartile is going to be 69.5. My median is 72.5. My third quartile was 79, and my largest value was 84. Okay, so again, I encourage you to please double check that math, but that is what I believe is accurate. So if we made this into a box and whisker plot, so let's say if I said, green was Interstate A, and we'll say blue is B. Okay, so if I went to the green, looks like if I went, so here's 59, and then I go, there's 66, 68 is probably right about there, and this is 75, and we got about 82. So that's A. So now if we looked at B, B 65 would be right about there. And then, so the first quartile would be right about there, I'll say, in conjunction with what I wrote before, 69.5. My median is 72.5, which is right about there. My third quartile is 79, and my largest value is 84. Okay, so you know, looking looking at this box and whisker plot, you know, you can make make the argument that the the range of speeds in miles per hour, the range is much greater in Interstate A than it is in Interstate B, just because of the looking just looking at um, our display. And also, with respect, to the median, and just by, kind of, they both appear to be symmetrical. So, but yeah, so I think that's the only thing I can kind of take from it is the range, the range seems to be much more spread out in Interstate A as it would be for Interstate B. If you guys think of something else, please let me know. The last thing we're going to look at is looking at displays that could possibly be misleading. Okay, when you have a misleading graph, it is a statistical graph um, that is not drawn appropriately. It may occur when creating of a graph, and you want to give the viewers an impression that the results are maybe better, or something appears to look uh, even worse than what it maybe isn't interpreting. So if you look at these two charts, the first one is talking about college tuition um, over the course of 4 years. And if you look at this, it looks like, oh man, it looks like it increases, you know, quite high, quite rapidly just because of how big the boxes are. But in reality, it looks like between, 2011 and 2007, it only went up, $1,500. You know, if you tried to tie that in, about $1,500. So it's if you try to tie that into, percentiles, you could say that that was only an increase of like maybe 9%. So it doesn't it's not that big of an increase as the graph maybe represents. If you look at B here, you can see like they're talking about the mean hourly wages for employees at a fast food restaurant. You're thinking, oh, between 2008 and 2013, it went up quite a bit. But if you look at the increments and how it was drawn up between 2013 and 2008, it only went up 15 cents. All right. It seems, the graph seems misleading because you're thinking like, oh, look how much more our wages were in the last, 5 years, but in cents, it only went up 15 cents. Okay, not a big um, increase, not even a big percentage increase. I believe it was, um, it would be what? Yeah, that's less than 2%. So it's about 1.6% increase in 5 years. And yeah, it could be misleading. Absolutely, for sure. And that is being able to choose a data display. Hope this helps. Until next time.